Now that we've learned several methods of solving quadratic equations, you're probably wondering, which method should I use? Now, I do have students who will just pick the quadratic formula and use it every single time. I'm not going to stop you from doing that, but I would also like to just say that that's probably the most tedious of the methods. And so if there are opportunities to use the other ones, they can be a lot more efficient. So let's just run through the strategy here. There is an appropriate and efficient time to use each of these methods. So here's how I would approach this. First, I would just look to see if you can apply the square root method because it's really quick. So that would be when your equation has only an x squared, there's no x, or again, you have something squared and there's no other variable outside those parentheses. I would use the square root method in that moment. Get the thing being squared by itself on one side and then just square root. Don't forget the plus minus. That is definitely the most efficient method if you can use it. But that's a not rare, but that's a specific, a particular opportunity. Otherwise, if you can't do that, you're gonna for both the other methods, you need to get everything on one side and 0 on the other. So do that. And then at that point, I always just look to see if I can factor it. Because in my world, maybe not yours, factoring is going to be faster and easier than applying the quadratic formula. But there are some equations that will not factor. And if it doesn't factor, then my last method is I'll default to the quadratic formula because that will always work, right? So that would be my advice on approaching solving any quadratic equation. So in your homework, in fact, I mean, I don't know if what the directions might tell you on some of them what method to use, but on a lot of them it might not. And so I would advise approaching it this way. So let's walk through a couple of these. So let's see, this first one. I do have an x term, so I'm not going to be able to use the square root method, which means I'm going to work on getting everything on one side, 0 on the other. And I'm pretty sure I can factor that. That's a straightforward factoring problem with only one x squared, two numbers that multiply to 3, but add to -4. And then I'll set each factor equal to 0 and solve. So certainly I would still be busy plugging and chugging away if I was using the quadratic formula right now. All right, let's try B. Oh, look at this. B does not have an x term. That leads me to believe that I should be able to isolate my x squared. Add the 3, divide by 4, and so now I can square root both sides. Don't forget the plus minus, and I'm done. Again, I would barely be at the plugging in stage if I was using the formula. Okay, so go ahead and pause and try C and D. Let's see how it goes. So because I do have an x term in this one, I'm not going to be able to use the square root method. I moved the 6 over, and I cannot factor that. There are not two numbers that multiply to give me -6, but add to give me -2. So I'm defaulting to the formula. -b plus or minus the square root of b squared minus 4a times c all over 2a. I figured out my number underneath the square root first, 28. 28 is 4 times 7. So I simplified that to 2 root 7. I do have a common 2 in the numerator, so I pulled that out front. Sorry, my denominator 2 is hiding here. 2 times what was left was 1 plus or minus root 7. And now I can cancel these 2's because this 2 is only being multiplied. It's 2 times this stuff. It's not 2 plus anything. So I can simplify those to get 1 plus or minus the square root of 7. And then last but not least, it looks like I can use the square root property on this last one because it's just something squared and numbers. So I added the 4 over, square rooted both sides. It's a nice whole number. So when I add the 3, I have 3 plus or minus 4. So 3 plus 4 is 7, and 3 minus 4 is -1. So I should simplify that. I should take that all the way to the end if they are whole numbers and get the two actual whole number solutions.